Okay guys, so just a short little introduction to electrostatics. Tomorrow we're going to do the tricky stuff, the maths, the quantization and conservation for electrostatics. But for now, just a little introduction to get you used to it. Definition firstly, electrostatics is the study of electric charge which is at rest or static. Static means it's not moving, okay? Now you get two kinds of charge. You get positive charge and you get negative charge. We've seen that before. Those are protons and electrons. And now when an object can experience three different types of charges. So there exist two charges, positive and negative, and then the combination that you have of those two types might end up in one of three different types of net charge. So you can get a zero net charge, so that's this first column in the table, which basically means your object is neutral, and that occurs when your object has an equal number of negative and positive charged particles. So basically it's got the same number of protons as it has electrons. So if we look at the little diagram here, if you count there, we've got 6 little plus signs and 6 little minus signs, which means that the net charge is 0 because 6 plus negative 6 is 0. So we've got a neutral object. Then the next option we have is a positive net charge. So positive net charge means you're going to have more positive charges than you have negative charges. So more protons than you have electrons. So if we look at the little diagram here, you can see we've got 6 plus signs and 4 minus signs, and we have 6 plus negative 4, which gives us 2, which means our net charge is positive 2, which means our object is positively charged. I mean, you can sort of think this through logically, right? If something's got more positive than it has negative, it means it is positive. Okay, and then the third option is if we have a negative net charge on an object, and that is when your object has more negative charge than it has positive charge. So here again, if we look at the diagram, we've got 6 positive charges and 9 negative charges, and 6 plus negative 9 is negative 3, so our net charge is negative. Our object is negatively charged. Now when an object, we're looking here now, when an object becomes charged, there's only one way that an object can become charged, and that is through the movement of electrons. Okay, only negative charge can move. We've seen that your protons are fixed in the nucleus, your protons cannot move, your electrons however can move. Okay, so in order to make something positive, that means electrons were removed from the object. Okay, please remember that. If electrons are removed or if negative charge is removed, it means your object becomes positive or becomes more positive. Okay, we could have an object that is negative and we remove some of the negative, but it's still negative, but just more positive than it was. Then the other option is if negative charge is added to your object, then your object will become more negative. Okay. Now, the triboelectric effect, just sort of a small section in here. It's what we refer to as static electricity in our everyday lives. Triboelectric effect is when you take, so this occurs when you have insulators actually. So, for example, when you rub your feet on the carpet, then negative charge is transferred from you to the carpet, which means you become, oopsie. Okay, that's wrong. I will edit the note on OneDrive and on WhatsApp before I send it to you. So if negative charge is transferred from you to the carpet, then you become positively charged, and the carpet becomes negatively charged. So if negative charge is transferred from you to the carpet, you've lost negative charge, so you become positive, and the carpet has gained negative charge, so it becomes negative. And then when you go and shock someone, when you go and touch them and shock them, then what you're actually feeling is the transfer of negative charge. Okay, so if you are now positively charged and you touch somebody, then electrons are going to flow from them into you to try and neutralize your charge, and that's the shock that you feel, is that movement, that transfer of electrons. Okay, then electrostatic force, electrostatic force, another non-contact force. So this is a non-contact force exerted by non-moving or static charges on one another. Now electrostatics and magnetism are quite similar, not completely similar, but they're quite similar. So with electrostatic force, Again, like charges repel each other and opposite charges attract each other. And again, the closer charged particles are, the stronger the force is that is experienced. So very similar to magnetism in terms of electrostatic force. Then our attractive forces, if you have a negative and a positive charge, they will experience forces of attraction. If you have two like charges, they will experience forces of repulsion. And then there's a little question for you on electrostatics. Okay, very, very straightforward stuff. It gets trickier when we have to now bring in the maths. Okay, but before we can start the maths, I just want to make sure you've got a basic understanding of how charge works, how something becomes positive versus how it becomes negative. That transfer of charge is tricky. If you lose negative charge, you become more positive. And if you gain negative charge, you become more negative. Please make sure you remember that. Okay, so that's it. 5-minute video and just one little question to do for me, or two little questions to do for me. Okay.